Good day, my name is Marco, and I came here to tell you about face detection in images using an FPGA. At first, I will show introduction, and later on we will go through proposed solution, its results and conclusion. Face detection allows digital system to determine the existence of a face in an image. That application opens new possibilities in a wide range of industries. Here we have examples of automotive, multimedia, arms and defense, and video game industry. The proposed solution is based on a Viola-Jones algorithm described using VHDL. Digital design for the proposed solution consists of three main parts. I/O is the first part, and its purpose is to input images and output processed images using AXI4-Light protocol. The last part is classifier parameters. It is borrowed from OpenCV, and it presents a structure of parameters used for face detection. This brings us to the middle part. Face detection top detects faces in an image using given classifier parameters. At the start of image processing, image is saved to I/O BRAM. Next step is the calculating of integral image, which gets saved into integral image BRAM. Process of face detection starts on integral image, and when a face gets detected, next subblock draws a frame around detected face. The managing unit manages subwindow and subframe addresses in a way shown on the image. Face detection is done inside the subwindow, which gets moved around the subframe. When detection inside the subframe is done, subframe gets moved to next position, and new face detection is started inside the subwindow on the new subframe. When subframe gets moved through whole input image, managing unit increases the index for image scaling. Downscaling is done inside the subblock image scaling, and it downscales previous input image by factor 2 using the shown method. Here we can see that image is scaled by translating 1 in every 4 closest pixels to the new scaled image. Subblock detecting face gives a binary decision as a result of finding the face. In this subblock, hard features gets calculated, normalized, and classified with the help of earlier mentioned classifier parameters. Let's see what are the results of the proposed solution. Used FPGA is ZINC, and here we can see the table of its resources. The main bottleneck to this design is the amount of BRAM memory, which limits the size of integral image and precision of the classifier parameters. Implemented design uses 1.728 watts at operating frequency of 55.56 MHz, of which 1.555 watts goes to SoC that can be swapped out in the future designs. Here we can see some examples of result images in comparison of the FPGA solution and similar solution in MATLAB. Difference in solutions is in precision. FPGA uses less precise values than MATLAB when detecting faces, which lowers down the detection threshold that forces FPGA to slow down and detects more faces than MATLAB. Even we mentioned difference, we can see that FPGA detects faces faster than MATLAB. Okay, so let's move to a conclusion. Implementation of face detection using FPGA achieves higher energy efficiency and up to 14.33 times better performance at higher recall and lower precision than the MATLAB implementation. Implemented solution can be used for applications with prioritized energy efficiency. In the future works, more DSPs could be used, classifier parameters could be better trained, power management could be implemented, and AXI4-Light protocol could be implemented without the use of SoC. Thank you for your attention.
Thank you, Marko. Do we have any questions or comments from the audience?
Ismail from Chalmers. Thanks for the nice presentation.
Thank
I
you.
would like to comment that the specific DSP processors, they might be helpful in your cases, such as the National Instrument ones. We were actually using those boards in our past, and we have seen that they are very efficient compared to FPGA processors.
Yeah, that's my design flow, and I would like to implement it using DSPs in the future design to bring up the operating frequency.
Yeah, perfect.
Do we have eventually other questions or comments? Maybe Marko, considering that we have time, we were pretty quick. Could you give us maybe a short overview about selection of the algorithm used for phase detection? And also, I have a comment concerning that I have relatively pretty old the camera for the family use, which is, let's say, about 10 years old, which has really nice phase detection features. So I'm just wondering what could be the implementation of the phase detection algorithm in those, let's say, old devices. And concerning that, could you give us an idea how you made the solution, how you choose the algorithm that you have analyzed?
FPGA is good with a bunch of data, like working in parallel. So, and it is good for image processing. I was kind of forced to do the Viola-Jones algorithm because of the images in grayscale.